Welcome to my channel. Today we are looking at how to use algebraic substitution to integrate trigonometric functions. Now, so we'll look at various examples just to ensure that you grasp the concept of integration on trigonometric functions. First, I begin by giving you the following formulas, which you will find to be very much useful in our integration. Now, you've already done the derivatives of these trigonometric functions. For example, you already know that the derivative of sine of x would be cos of x, and the derivative of cos of x would be negative sine of x. But this time I'm giving you the formulas for integration. And now we must know that the integral of sine of x will be negative cos of x plus constant of integration. And the integral of cos of x will be sine of x plus constant of integration. And the integral of sec square x will be tan x plus c. The integral of cosec square x will be negative cot x plus c, and the integral of cosec x, cot x will be negative cosec x. The integral of sec x tan x will be sec x plus c. We have so many trigonometric functions, and we have so many, we can get the integral. So this is just a few, but as we progress with the integration, we come to learn several other formulas. Now let's look at examples on how to use the formulas I've just given you. So the first one, we want to look at the integral of 7 cos 5x, and then the second we shall look at. So we'll be looking at these questions. Now what you notice is that in my formula, I gave you the integral of cos of x dx. And this was sine x plus c. But in the first example that we are saying here, this is not x, this is 5x. So this is more than x. And if this happens, then we must let this to be. Because you only need one variable at this point. You just want something like x or u at this point, not 5u, not 5 theta. Not 6 something, just want u here. So for us to integrate this, the first thing that as I've already stated, we'll equate this to u and then differentiate. And that one I've done it for you. Let me just show you what I did. So for me to do the integral, this integral, since I noticed that this is not x, is something more than x. So what I've done is I've let this to be u. So let u be 5x. And then when you let u to be 5x, differentiate this. Find du dx. So when you find, or just differentiate, when you differentiate this, on the left you'll find du is equals to, on the right you'll find 5 dx. And then make the x the subject of the formula. Make the x the subject of the formula by dividing both sides by 5. That's what I did. That the x becomes du out of 5. We are now ready to integrate. And as I said, we want to use substitution. So we are substituting this. Instead of 5x, we substitute this with u, and instead of the x, we substitute this by du out of 5. And so that's what I did, that this integral is the same as this, 7 cos of u. So u instead of this. And then instead of this, I have du out of 5. At this point, I can take the constants outside the integral sign. And when you take the constants outside the integral sign, you can see that our constant is 7 out of 5. So it's 7 out of 5. We are left with the integral of cos of u du. This we know how to do it. We know how to do it because our formulas already told us that the integral of cos of x dx will be sin x plus c. So that means the integral of cos of u, if this is u du, if this is u du, then it will be sine of u plus c. So that is what we have. That we have 7 out of 5 sine of u plus c. So just substitute what was u. Our u was 5x. So that is our final answer, therefore, is 7 out of 5 sine of 5x plus c. So this 5x, we're getting it from here. It was the u. It was this u. And so that's how we integrate this. Now, what I will notice is that we can do this thing mentally because what we were given was 7 cos of 5x dx. We need to know how to do this thing mentally because a time will come when we have more complicated integrals. And when we come across this in our integration, at that point, when we are dealing with complicated integrals, we need to know how to do this part mentally so that we do not waste a lot of time. Now, so when I look at this, I can see the 7 and the 5 in my final answer. That what was here is divided by what was here. So I have 7 out of 5. Then I've just integrated cos to be sine and inserted this, inserted that, then added constant of integration. So it's very easy when I look at this, and I've written that in some general notes here. I've written that in some general notes, and I've said generally, if you're given a function, the integral of L cos of bx dx, then the integral of this can be written mentally by just taking A divided by B. A divided by B, then integrate this cos to be sine and insert x. Insert the x, then add constant integration. And that can be seen in our example B. Example B, we are told to integrate 12 cos of 7x dx. So without going through much work, we know that it will be 12 divided by 7. 12 divided by 7. Then the integral of cos is sine. And just insert 7x, then plus constant of integration. And so that's how we do it. And let's look at a different example. That was example C. Example C here. The question is, integrate this. This is what we want to integrate. But just as in our example A, what we know how to integrate is this. We know how to integrate sine of x dx. And we know that this is negative cos of x, then plus constant of integration. This we know from the formulas we're given above. But looking at this question here, this is not x. This is more than x. So we must equate it to u, just as we did in the first example. We equate this to u and then differentiate. So that's what I've done. Let u be 4x. Then differentiating this, the left side, differentiate the left side, I have du, and the right side, I have 4dx. 4dx. Make dx the subject of the formula. By dividing both sides by 4, you will find that dx equals du out of 4. We are now ready to integrate by substituting this with u and this by du out of 4. So that's what I did here. So it's the same as the integral of 9 sine of u. Instead of dx, we have du out of 4. And then as in the first example, take the constants outside the integral sign. Then the constant here is 9 out of 4. So 9 out of 4, the integral of sine of du. But what is sine of u? The integral of sine of u. The integral of sine of u is negative cos of u plus a constant of integration. So doing that, we get negative 9 out of 4 cos of u plus c. We just need to substitute the u here because it was not in our original question. What was in our original question was 4x. So bring the 4x back. And what you have is a negative 9 out of 4 cos of 4x plus c. This is our final answer. Now, again, we can generalize this, and we are looking at this question. We are saying that what we had was 9 sine of 4x dx. And when you look at our question, at our answer, what we have is 9 out of 4. So the constant here over the constant here, so 9 out of 4. Then the integral of sine is a negative cos, and in part the 4x, then plus constant integration. So we can write the answer mentally, actually, without going through much workings. So I've written that as a general note, and I've said generally, given the integral of a sine of bx dx, the answer to this can be written mentally as negative a out of b cos bx plus 2. So I've given one example to show this. Given one example, that is part D. And in part D, we are asked to get the integral of 2 sine of 9x dx. So whenever I say this, I realize that this is not something to waste a lot of time working out. The answer will just be negative 2 out of 9 cos 9x plus c. The answer can be written straight away. Now let's look at another example. So we're looking at example E, and we are asked to integrate this. And there's something that we know from our formulas above. From our formulas above, we know that the integral of sec squared theta d theta is the same as tan theta plus constant of integration. So that we know. But this is theta. What we have here is 9 theta. So that means this must be equated to u. Yeah. The examples are now clear. We've already seen 2 examples above how we've been doing that. That whenever this is more than what we have here, or whenever it's different from what we have here, then we have to equate it to u. So let u be 9 theta. Differentiate both sides. You get du equals 9 d theta. Make d theta the subject of the formula, and if that happens, you have divide both sides by 9, and then you get d theta is du out of 9. Now come back to your integral, and this is the integral. So just substitute. Where there is 9 theta, put u. And where there is d theta, put its equivalent, which is du over 9. Du over 9. So and then check the constants outside the integral sign. Our constant here is 4 out of 9. So I have 4 out of 9. Integral of sec squared u du. But this we know From here, we know that it's tan u plus c. So this is 4 out of 9 tan u plus c. Then bring back the equivalent of u was 9 theta. Because u was not in the original question. What was in the original question was 9 theta. So bring 9 theta back. And this is supposed to be 9 theta, not 9x. 9 theta plus c. So again, you can generalize it. And you can see it's 4 out of 9 tan. 4 out of 9. So you're just taking from here, from this. You can write the answer mentally. It's 4 out of 9. The integral of sec square is tan. Then insert 9 theta plus c. And that I've written it here as just a general remark. And I've said that if you're given an integral of this kind, the answer can be written as a out of b tan bx plus c. So that is in our example F here. In example F, I'm not wasting energy doing it because I know that it can be done mentally. So my answer straight away is 11 out of 13 tan 13 theta plus c. So let's go to another example, slightly different. This time we're looking at 13 times the integral of cos x squared 4t plus, no, dt. But what do we know about the integral of cosec from our formula? Cosec squared theta, d theta. From our formulas above, this is the same as negative cot theta plus constant integration. So that's what we are doing, but I'm looking at this point. What I'm seeing here is 4t. So I let it be u and differentiate both sides. The left side will give me du, the right side will give me 4 dt, and then make dt the subject of the formula by dividing both sides by 4. And when you do that, you find that dt equals to du out of 4. Now come back to your question and substitute. 13 times the integral of cos x squared 4t dt will be the same as 13 integral of cos x squared. Instead of 4t, we have u, and instead of dt, we have du over 4. And then the constant taken outside will be 13 out of 4, the integral of cos x squared u du. But this we know. It will give us negative cot u plus c. So, multiplying that, I will have negative 13 over 4 cot u plus c. Substitute back your u, which is 40. So it will be negative 13 over 4 cot 4t plus c. So generally, again, when you're given an integral of this kind, integral of a cos x squared dx, the solution will be negative a out of b cot bx plus a constant integration. So, for instance, in example H, this integral can be written mentally as 10 out of 9. And the integral of cos x squared, it will be negative cot. And then insert 9x plus constant integration. So you have the answer without much work. And what I want you to know is how to do some of these things mentally, so that to reduce your workings. Because you might come across another question that requires a lot of working, and if you can do some mentally, it will reduce on your time and space and your workings. And let's look at this other question. This is not different from the first question. It's not different. We can write this answer mentally. But let's again just do it. We know that the integral of cos theta or cos x, the x is sine x plus constant integration. But what I have here is not x. So I equate it to u. So let u be 5x plus 13. And so on the left side, du equals to 5dx. Remember that the derivative of a constant is 0. So the derivative of 13 is 0. The derivative of 5x will be 5dx. So that gives you 5dx. Now dividing through by 5, you get that du equals to dx equals to du over 5. Which means that the integral that we are given, when we substitute these values that we have here, we can do it. It becomes the integral, instead of this, to the cos u. Cos u, instead of dx, we'll have du out of 5. Take the constants outside the integral sign. We'll have 1 out of 5. The integral, of course, of du. And this is the same as we know this. This is sine u. When you integrate, it will be sine u plus c. And then bring back the equivalent of u, which was 5x plus 13. And you have the answer. So I stated that we can do this mentally because we've already done it before. So I know the value here is 1. So it will just be 1 out of the constant here, the coefficient of x. The coefficient of x is 5. And then the integral of cos will be sine. And put whatever is here, which is 5x plus 13. Then plus constant integration. So you can do it mentally. And so that's how we look at how we integrate by substitution when you're given trigonometric functions. But there are various examples we look at. In our next video, we look at various other examples of integration by substitution.